everyone. Today I am presenting you video number 4 for lesson number 5, periodic classification of elements. This is the last video completing this chapter and also completing the syllabus of class 9 chemistry. So till now we have discussed modern periodic table and we have seen that it was definitely much better than Mendeleev periodic table. Now today we will discuss the trends in some important properties of the elements down the group and along the period, that how certain properties are changing in a group and in a period in the periodic table. So first let's see which properties we will be discussing today. These are your valency, atomic size, metallic character and non-metallic character. So first let's begin with the valency. You all know that except noble gases, atoms of all other elements take part in chemical reaction by combining with the other atom. Okay, they do so either to complete their octet or duplex, and this combining capacity of any element is known as valency. Okay, this much you know. The combining capacity of an atom of an element with the atom of other element in order to acquire 8 electrons is known as its valency. So if we see now, all the atoms present in group, they have same valency. You know this because group represents the valence electron of an element. So in a group they will be having same valency. For example, lithium, sodium, potassium, they all have valency equal to 1. If we talk about group 2, it is beryllium, magnesium, calcium, they all have valency which is equal to 2. So it can be said that in a group all the elements have same valency. There is no change in the valency. You can see in the slide also. Now what happens is if we go along the period, because you know period is a horizontal row and the elements present in the period, they don't have the same valence electron. Okay, so therefore they will not have same valency also. It can be said that in a period elements have different valencies. Now if you will try to see, then you will see the valency is increasing from 1, 2, 3, 4, and then what you will see, then it is getting decreased from 14th group elements. It is from 4, then 3, then 2, then 1 and then 0. So here it can be said that valency of elements in a period first increases from 1 to 4, okay, and then it will be decreased from 4 to 0. Okay, so this is the first trend of valency we have studied, that valency is increasing first in the period and then it is decreasing, and in a group the valency remains the same. Okay, this was there. And you know atoms having 1, 2, 3 valence electron, they show 1, 2, 3, 4 valency, which are having 5, 6 and 7 valence electron. They take up 3, 2 or 1 electrons respectively, and thus they show 3, 2 and 1 valency. In a group same valency. In a period first it is increasing and then it is decreasing. So now let's come to our next trend, that is atomic size. Atomic size there are specific for each of the atom. And what is actually the atomic size? It is the distance from the center of the nucleus of an atom to the outermost shell. Okay, and atomic radii can also be defined as the shortest distance between atom's nuclei and the outermost shell. In the picture you can see what actually the atomic radius is. Now if we talk about groups, so here you can see the electronic configuration is increasing down the group. Okay, lithium, it is having 2 shells only, K and L, then sodium having 3 shells, potassium having 4, rubidium having 5 and cesium having 6 shells. So you can conclude here that in a group, as we are moving, then there is increase in number of electrons and there is increase in number of shells also. So when the shells are increasing, the atomic size or the atomic radii also increases down the group. Because shells are increasing, so it is increasing the distance of atomic radii for an atom in a group. Okay. Now what happens is in a period. In a period, if you see from left to right, the electrons are added in the same shell, because we know period shows the number of orbits. Period 2 will have only 2 orbits. Okay, this is period 2 only in the slide. So they have only 2 shells and number of electrons are getting added. No new shell is formed. Okay. Like lithium, it's having 2-1 configuration, beryllium, it is having 2-2, and so on. Means the electrons are increasing, but there is no increase in the shells. So, you know, nuclear charge, it is due to the number of protons and it increases from left to right because number of protons are also increasing in the nucleus. So, what does it do? The electrons are experiencing more attraction, more positive charge in the nucleus. So electrons are attracting towards the nucleus, and as a result, the atomic radii decreasing from left to right. Okay. Atomic size decreasing from left to right, that is in a period, because of the increased nuclear charge. Because the number of proton is increasing, so electron is getting attracted towards the proton and thus reducing the size of the atom. And atomic size is increasing down the group because of the increase in the number of shells. Okay. Now metallic and non-metallic characters. So you know the metals are present on the left side and also in the center in the periodic table. Non-metals are located on the right side, and metalloids, they are present in the borderline. They are shown by some zigzag lines. In yellow you can see the metalloids. Okay, so how we tell that this substance, this element is a metal and this is a non-metal? We have studied this in lesson number 3, metals and non-metals. And you know that by losing one or more electrons from the valence shell, the metal atom changes to positive ions. Okay, and metals are therefore regarded as electropositive in nature and non-metals are regarded as electronegative in nature. So if we talk about group 1 elements, lithium, sodium, potassium, rubidium, cesium, they all are metals. But how you will tell that which is more metallic in nature? Let's see how we can show this. This is lithium, sodium and potassium. Okay. Now here what is happening, you can see there is increase in the atomic size. Lithium 2 orbits, sodium 3 and potassium 4 orbits are it's having. Okay, so as the atomic size is increasing, the hold of nucleus on electrons decreases and therefore the tendency to lose electrons increases because the hold is decreasing. When the number of shells are increasing, the hold of nucleus on electrons decreases and thus electrons can be shared or electrons can be lost. Therefore, metallic character increases down the group because down the group what is happening? The atomic size is increasing. When the size is increasing, then the atom can lose the electron. So, sodium can lose the electron. It has a more tendency than lithium, and potassium is having more tendency than sodium also. Same way rubidium and then cesium has the maximum tendency because it is having greater number of shells. Okay, so metallic character increases down the group. But what happens is along the period, metallic character is decreasing. Why it is decreasing? The reason must be clear to you because what is happening in a period? The atomic size is getting decreased. So when the atomic size is getting decreased, the attraction of nucleus for electrons increases and the release of electrons decreases. Okay, more the atomic size, less is the attraction and more is the metallic character. Okay, and vice versa for the period, because there is a decrease in atomic size, attraction of nucleus increases, and therefore release of electrons decreases. And the reverse will happen for non-metallic characters. The non-metallic character of an element is due to accepting the electrons. Okay, and by accepting electrons, non-metal changes into a negative ions. So what will happen down the group? Down the group, metallic character will decrease because the electron accepting tendency of the atom tend to decrease due to increase in size. When the size is increasing, then there is a decreased tendency to accept the electrons. And along the period, what is happening? The non-metallic character is increasing because electron accepting tendency is increasing due to the decreased size of the metals. Okay, so down the group, non-metallic character decreases because of electron accepting tendency decreases due to increase in size, and along the period it is increasing. This is just the reverse of the metallic character. So in short, it can be said that metallic character decreases in a period and it increases in a group, and non-metallic character increases in a period and decreases in a group. So this presentation completes your lesson number 5 and also the syllabus of class 10th chemistry. Thank you so much.